He kōna ipurangi tēnei nā te reo irirangi o Aotearoa.
On a nice day, Antarctica can be a really lovely place, even when it's minus 13, say. If the wind's not blowing, it's completely manageable. But the weather can turn on a dime, which is what it's done with us today. From quite calm and sunny this morning, it's now overcast, it's blowing a strong wind. And I'm sitting in my tent and you can hear the tent being buffeted by the wind and also snow being blown against it. And it's not actually snowing, it's just that the wind is rearranging all the other snow around, so it's like being our own little ground level storm here. To be honest, I think the team would go out if a bird came back, but it would be really unpleasant working out there at the moment. Kia ora, hello. Welcome to Voices from Antarctica from RNZ. I'm Alison Ballance, and we're up to part 5 of our audio exploration of living in and doing science on the frozen continent. I'm still at Cape Crozier on Ross Island with a team of researchers studying emperor penguins. They're waiting for half a dozen birds feeding out at sea to return to their colony on the sea ice. These birds are carrying small data loggers on their backs. The team retrieved the loggers from one bird just before I arrived, and Geeta McDonald is in the kitchen and living tent, staying out of the wind. So can you tell me what you're doing? You're sitting looking at your computer.
We just plugged in the tag that we collected from a penguin today.
So what data are you collecting?
So this is an axi-trick tag that collects depth, acceleration, so we can see how it's moving in 3 dimensions, and GPS, so we know where the bird's going, how deep it's diving, and how hard it's working.
Exciting.
It is exciting.
So how long was this tag deployed on a penguin for?
We deployed it the first day, so 17 days. It's our longest deployment so far. So with the download completed, and we've now been able to plot the track, and we're going to see where it goes in comparison to the other birds. So the new bird is this blue one that actually goes off of the map because it went so far away. And my guess is that it went at least 250 kilometers out and 250 kilometers back. So pretty impressive.
By the time you add the diving, you're probably looking at least 1,000 kilometers.
Yeah, I think this might be one of the longest foraging trips that I've seen.
It looks like the birds are doing quite different things. They've got their own little foraging tracks and destinations and strategies.
Yep. The most consistent thing is that 4 of the birds headed east, but then once they get about 100 kilometers east of the colony, they all went their different ways. 2 birds pretty much just went directly north, and 1 bird went west around Ross Island. So they are doing very different things.
That's just a track on a white background, so you don't know what it is that's on the seafloor that they might be going to, they might be responding to?
Not yet. Based on kind of what I knew going in, I think about 150 kilometers northeast of the colony, there was the edge of a bank, still 400, 500 meters deep, but there is shallower water about 150 kilometers from the colony, and it looks like at least 4 of the birds might be using that area.
How many days was that trip?
17 days, which is within the normal range. Mean trip duration of Ross Sea emperor penguins is about 14 days, typically ranged between 7 and 21.
What is the penguin doing when it's not just tootling along at the surface, is it?
No, most of the birds have been diving down to over 400 meters. So this is a kind of a typical dive profile of what we've seen. So this is one of the birds we tagged, which was a 14-day trip. So when it first left the colony, it was doing dives of about 150 meters. But then as it got further out on day 4, it looks like, it started to perform dives down to over 450 meters.
Wow, and it looks like it's bounce diving, like going down deep, coming back up to the surface to breathe, I presume.
Yeah, the short dives a lot of them actually look like V's down and straight up. Some of the deeper dives, they spend a little bit of time on the bottom, not much, because they have to spend so much time in transit. But some of those deep dives, they're 10, 12 minutes in duration, and then the birds come up, and it's often followed by a few minutes at the surface or followed by some shallow dives. So we think when they're diving down to that depth, they are feeding potentially on the bottom, but we don't know what they're eating down there. So that's one of the reasons that we've been putting cameras on these tags. Is silverfish is typically found in the water column, as is krill, but these animals are, almost all of them are diving down to 400 meters. Once we plot this on a map, we'll be able to figure that out if they're diving to the bottom, and they might be eating something different down there. So we're hoping to get some of the camera data to figure out what they're eating on the bottom.
Can you work out what they're eating from their poos? You know, if you scrape something up off the snow, would you get a sense of what they might be eating from that?
You can. We are actually collecting some guano samples that we will be shipping to a collaborator, and the guano samples actually might reveal some of the benthic prey species, if they are feeding benthically, that we haven't been able to get from stomach lavages.
Those are amazingly deep dives for, you know, I know they're a big penguin, but they're still a small animal, really.
Yeah, it's pretty impressive. So when they start off at the surface, their heart rate is 220 beats per minute. They're rapidly loading oxygen. They dive down. It drops down to about 50 beats, continues to decrease on the really long dives. We have, recordings 10 beats per minute, and then it starts to increase as they surface again. So they're really good at conserving their oxygen. They decrease their heart rate. They likely do not provide much blood flow to their muscle. And so emperor penguins actually store a lot of oxygen, about 4 to 5 times more oxygen per kilo than a human. So by decreasing their heart rate, they can really maximize the amount of oxygen that they're using that's stored in their muscle. But the air that they take down with them in their air sacs, they can potentially keep moving that air through their lung and using that oxygen.
So just remind us, birds, they've got lungs and then they also have air sacs.
They do. Bird respiration is actually really cool. So they have an anterior and a posterior air sac. And so they actually move air in a circle. When the bird takes a breath in, it goes to the posterior air sac. When it exhales, that air from the posterior air sac goes into the lung. When they inhale again, so the air sacs expand, that air that was now in the lung gets pulled into the anterior air sac, and then it's not until their second exhalation that it actually leaves. And so it's a completely circular flow, and it's a much more efficient way to extract oxygen.
So what's the duration of those dives on average?
Most of their probably pelagic dives are going to be 5 to 7 minutes. The deeper dives are usually just over 10 minutes. The record dive is 27 minutes, but those dives are unusual, and they most likely result because the animal can't find a place to breathe.
Because, of course, there's a lot of ice around that, so that's, you know, they can come up to the surface and go, oh, crap, I can't.
Yeah, and there's also the potential that there's a predator where they were, going to come up. So there's a lot of possibilities that might prevent them from coming up. So they'll just swim below the surface until they find another place to take a breath.
Do you have any idea how much sea ice is out there? I'm thinking of that one who's just done that long 17-day trip.
They're probably out in the pack ice because most of the birds do have haul-out periods, so that means there is ice for them to rest on. We did get video from one camera, and there was ice in the 3-hour video, and they do take breaks on the ice.
The team fitted 5 penguins with video cameras, and that's the only one with a camera that's come back so far. Unfortunately, it did not eat during the 3 hours of recording. That's a shame, as they'd been hoping to catch glimpses of what it might be feeding on. In the meantime, while we wait for the remaining 6 birds to hopefully return, let's catch up with some more physicists. It might seem a bit of a jump, but both research projects, penguins and physics, are about understanding how climate warming will affect Antarctica and its inhabitants. Up at the Arrival Heights laboratory, back near Scott Base, I open a door and find Graham Plank. I am sticking my head in here to discover the source of your sound.
It is a radar that measures atmospheric winds between 60 and 120 kilometres altitude. They're global scale winds that transport ozone-killing nasties all the way to the pole. You can hear the pulses going off all the time. That's the transmitter firing at 30 pulses a second. And the fading up and down that you can hear, it's just a gentle waving. That is the atmospheric motion, so giant waves moving up and down in the atmosphere.
So how does it work?
So this is a MF radar system. So if anybody has seen a cloud moving across the sky with the sun above it, and you see a shadow that moves across the ground really fast, that's an optical effect. This uses radio waves in a very similar fashion. we use a transmitter at Scott Base to fire pulses up to the atmosphere, and then it goes up through the neutral atmosphere where there's nothing really that can reflect off until it gets to the D region, which is the area that we're interested in, which is the lower part of the atmosphere, about 80 to 100 k's altitude. The layers that we're looking at aren't perfect reflectors, they're wobbly. And so the reflection we get on the ground is a diffraction pattern similar to that shadow, and that shadow will move across the ground, and we have multiple receivers, and we'll receive it on one receiver, and then a short time later we'll receive it on another receiver. The pattern will have changed subtly because it's not a perfect reflector, so we have some computation which will do some analysis to figure out whether it's correlated to the first one. If it is, we know the speed across the ground, which is half the speed of the cloud because of the way the geometry works, and the timing from when we fire off our pulse to when we receive the signal gives us the height.
Is that a windy part of the atmosphere?
It's very windy, so we're measuring regularly winds 50 to 100 metres per second. So
Metres per second?
Metres per second, so that is going like the clappers.
Back at Scott Base, I tracked down Graham's Canterbury University colleague, Adrian MacDonald. I've heard the radar.
The radar that you were listening to, or the audio output from that radar, we send out something like a 100 kilowatt signal, and that bounces off the atmosphere, comes back, and we measure something like milliwatts. So that's about a millionth of the signal that we send up comes back. And from that, we can understand the winds and make measurements of the winds. So that's higher in the atmosphere. So it's where the ozone layer is, and above there. We've been measuring since 1982, so we have the longest record of its type in the Southern Hemisphere and possibly on the planet, which is great. So why I'm so keen to keep the instrument going, because it is somewhat of an antique, frankly, but that's okay, because it consistently measures the same thing. So as long as we keep it going, it's all very good. We also measure atmospheric tides and planetary scale waves. So just like the ocean has tides, the atmosphere has tides. Those are associated with the fact that there's a sunlit half of the Earth and a dark side of the Earth, and the temperature differential causes waves in the atmosphere. So we measure all types of waves in the atmosphere, and those are the things that transfer energy from the lower atmosphere into the middle atmosphere and vice versa. So for instance, the Antarctic ozone depletion has had a significant effect on Southern Hemisphere climate at the surface. So it's one of those things that's possibly slowed down greenhouse gas controlled warming over Antarctica a little bit. So it's acted as a brake when greenhouse gases are the accelerator, basically.
Can you tell me a bit about how that works?
Largely what happens is that the ozone hole basically strengthens the winds around Antarctica, and those winds basically keep the cold air over Antarctica and keep the warm air from the tropics and the mid-latitudes away from Antarctica. And by strengthening that circulation, you're keeping the cold air over Antarctica more often.
What is it about this area that interests you as a research area?
I'm really interested in atmospheric dynamics, how the wind and circulation patterns, how weather patterns, how they affect climate and things like extreme weather. One of the more difficult things to do in terms of atmospheric science and climate science is simulating the circulation patterns, because they in turn affect things like cloud formation and precipitation. And I've done lots of work in the Deep South National Science Challenge on cloud and precipitation as well. So I do lots of different types of climate research, but they're always somehow connected to circulation, how the winds are moving and how that affects the atmosphere that we see.
You said that because it's such a long record, you've been able to see change. What kind of changes have you been seeing?
So we've seen very strong solar signal variations. We've also seen weaker signs of climate change, but climate change in the stratosphere is a different sign than we would see at the surface. So in the stratosphere, as the surface warms, there's more radiation being trapped near the surface by greenhouse gases. That means that the stratosphere actually cools. Just to be very, very clear, I do believe that anthropogenic greenhouse emissions are having a significant impact on the climate. Sometimes it's hard to see that over Antarctica because we have relatively short records. It's also the place on the planet that's the most variable on the planet. So maybe 500 kilometres away from Scott Base, you've got a region called the Amazon Sea. That's the pole of variability on the planet. There's more variability in terms of the atmosphere there than anywhere else on the planet. So being able to see those signals associated with greenhouse gases or ozone depletion or El Nino, they're all really hard to see here. So it's a challenging environment in terms of logistics. And well, you saw that the weather today was pretty darn average. And
your fingers were very cold?
Yes, my fingers were really, really cold. And it wasn't much fun being out there trying to make that radar work and that antenna work. But scientifically, it's also a really challenging area to understand. And that's why I think there's so much focus on it in New Zealand and around the world, because it's really hard to work out.
So that's why it's a really good thing having that radar here in Antarctica.
Yeah. We work strongly with Americans, and there's about 3 or 4 of that type of radar around Antarctica, but they're all from the 1990s or 2000s. So we've got the longest record, and we're the only one over this side of Antarctica because most of them are over on the peninsula. That helps because the atmospheric tides I was talking about, they have a wavelength where they peak on one side of the Antarctic and they're a minimum on the other side, so that by having measurements across the Antarctic, we can understand those better as well.
Well, from stratospheric winds down to ground level. Back over at Cape Crozier in Emperor Penguin territory, the wind dropped, my tent stopped being quite so noisy, and I was able to get a good night's sleep, tucked up in my many sleeping bags. Who knew that sleeping on ice could be so warm and comfy? In the morning, I head out to commune with the emperors again. Good morning.
Good morning. So one of our penguins came back.
That is excellent news.
It is very excellent
And it's
news.
still moderately early in the morning.
It is, and I actually got to sleep until 8, so it's still pretty nice.
So which one came back?
Bird number 3. So it's carrying a data logger that tells us where it goes, how deep it's diving, and its fine scale movement, so you can reconstruct 3D tracks.
But it's not one of the ones with the cameras.
It isn't.
Oh no.
Yeah.
So this is going to be a bit tricky for you because the birds this morning have all bunched up against the Ross Ice Shelf, against the cliffs.
It is. It's actually moving left right now. You can actually see it walking left further into the group, which is not what we want. But we'll try to cut it off and see if we can move it just by moving very slowly. Have 1 or 2 people in the colony trying to move the bird out, and then we'll have the other 2 people waiting out here to hopefully catch it. So the goal is to isolate it from the group.
Well, good luck with that. I hope it is easy and simple to do. And I'll stand out here and watch.
Sounds good.
So you're going to be part of the catch team, Parker?
Yeah, the process in general, as soon as we capture the bird, to removing all the instruments takes about 10 minutes total, so it's a fairly quick process. But we'll be taking weight measurements, flipper length, and girth if we can as well, which will later go into our modeling when we're looking at how these animals are foraging at sea. A lot of the birds that we've gotten back have gained about 2 kilos.
Wow.
Yeah,
So
pretty
they're
incredible.
finding lots of food out there to eat.
They must be, yeah.
Well, some of the birds have come over to check us out, but not the one with the transmitter on it.
No, you can definitely see that there's some animals that are non-breeding, most likely, and they're quite curious. They'll come check us out. They'll even sometimes peck at our gear that we leave on the ground.
Okay, you might be in business. I'll
Yep.
let you get on with it.
All right.
Geeta's on her hands and knees, creeping amongst the penguins because she doesn't want to be seen. And when she was crawling in very slowly, she had a whole crowd of penguins following along behind her.
That's gone pretty well, eh?
That's gone very well. They've singled it out like a good shepherd with a flock of sheep. The team have the bird. They're removing the tags. weighing it,
32.9.
and now they're letting it go.
3, 2, 1.
It seemed to go pretty smoothly.
It did.
So you had 3 instruments on the back of it. So they were glued on.
They're actually taped and cable tied with just a little bit of glue.
And so the bits that are left on the bird, it'll just molt those off in January?
It will.
Cool. And how much did it weigh?
It weighed 25 kilos, so it gained 1.5 kilos since we caught it.
So how long has this one been at sea? So it was one of the earliest ones you put tags on?
This was the first day, and so it's been at sea 18 days. So far, this is the longest foraging trip that we have. So it will take us a couple hours to download the data and see what it did, but it will be fun to see where it went.
And in that time, put on 1.5 kilos, so it was clearly finding lots of food.
Yep. And it's already fed its chick a little bit, so there might have weighed a little bit more initially. But hopefully it'll go right back to the colony and continue feeding its chick and stay here for a few more hours before heading out to sea again.
One down.
1 down, 5 more to go.
I was thinking as you were doing this is such a challenging environment for you to work in, but it's also a challenging environment for all that equipment to work in.
It is. So this is one of the data loggers that we have. So this is the propeller that seems to get iced up. Let me see if I can move it now. Yeah, it's iced up. When we take it back, it will probably spin again. But this data logger that I'm holding has a propeller that can give us information on speed. It also has a magnetometer, so it can give you orientation. And it has an accelerometer, so it tells you kind of how it's moving forward and all the different axes. And that allows us to recreate a 3D track of the emperor penguin, so we can see kind of how it's moving and hopefully pick up things like a little burst of speed when it's going after a prey item or something like that. So these data loggers are kind of fun that we can try to create exactly what they're doing. You know, as soon as we hear that there's a bird, there's always a bunch of excitement, but it's always great to get our tags back and then also just to look back at the colony and see that it doesn't even really look like we've been there, which is always kind of my end resort. We get our tags back and the birds are just back to normal.
Well, one bird back, and the wind is back too. I'm venturing out in the wind, which is behind me, so it's easy travel at the moment. It's really interesting, the Adelie penguins are still trotting back and forth. But when it's not windy, they have their little flippers sticking way out the side. And now that it's cold and windy, they've got their flippers stuck down by their side. So even I think they don't like the weather very much. And I am headed to a flag, which is quite a bit windier and flappier than it was the other day. Oh, so we're back in your nice little warm cabin, which is not quite so warm. And since we went out this morning, the weather has packed a sad on us, so it's really windy and cold now.
It is windy and cold, so I'm really happy we got the bird back this morning. And we just spent the last few hours downloading the data. So we have to unwrap the tag, wash it off, download it, and then we just converted it. And now we're just looking at the data for the first time. So this is the figure.
Da-da-da.
So it should be orange. So the bird actually went around Ross Island. This might be Beaufort. It looks like the tag failed, actually. We don't have a return path. So I'll have to go back and look at when that happened. But the 4 birds so far have all gone east. This bird went west, kind of along Ross Island, and then up, it looks like along the continent before it failed. Similar, we've had one other bird go that direction. So yeah, it'll be fun to look at the diving data to see if it's doing something similar to the first bird we tagged.
What a shame it didn't last all the way, because it was out there for quite a while.
It was. It's a little disappointing. This is the first time one of the tags hasn't lasted the entire trip. The memory wasn't full and the battery was good. So I'll look at the diving data, because it might just be that for some reason the GPS failed and we'll still have all of the diving data. But that will be another 2 hours.
And now I am heading out. It's about an hour since I last recorded those flags, and this is what it sounds like now. just a gentle breeze. The weather here is amazing. There's still dark clouds out on the horizon. There's lenticular cloud over Mount Terror, I think it is, which is the peak on the other side above the Cape Crozier penguin colony. The sun's shining and it's pretty calm, and it feels so much milder than it did just an hour ago. Still got cold fingers though. So the 2 hours have passed and you have the diving data. For a start, did it record beyond the 7th of November?
It didn't. It stopped at the same time, but we still have almost 10 days worth of data. And hopefully we'll be able to get the rest of the data off the tag, but we may have to send it back to the manufacturer. But this was a deep diving bird. It had probably 8 foraging bouts that we recorded, so long periods of foraging. And on all of those dive bouts, it went to over 400 meters. Its deepest was about 490. So the record's about 530, fairly close. But the fact that it was routinely diving so deep is a little bit different. And I actually was just comparing this to the bird that went to the same location, and it actually has fairly similar behavior. So they're probably foraging on similar things.
If only we knew what that was.
I know. If we get those cameras back.
Any birds?
No birds.
So how many times have you been to Antarctica?
This is my 12th time. So.
And what are the highs and lows of working here?
The highs are, it is the most beautiful place I've ever been. The nature is amazing. The people I meet here are amazing. The lows, bad weather days. I guess some of the things I miss the most are showers.
So no showers at all while you're out here in the field?
Nope. So this is only 3.5 weeks. The longest I've gone is 6. So this is not too bad. But this is one of the things that's amazing about these kind of camps. I love being away from everything. Like, we have no email, we have no internet. So you actually just get to focus on the science and, you know, kind of making sure camp is safe, cooking. And yeah, it's one of my favorite things. And it's something that very few people get to do anymore, to actually step away from it all for three weeks.
And your daily commute is a 20-minute walk across the ice
to
the colony.
Yep, it's a great commute. It's a beautiful night. Hard to believe that, 2 hours ago it was a lot windier, a lot colder. So nice to get out in this. Now we just need a bird to come back.
Yeah.
Or 2.
Or 3.
It's time for me to leave. Geeta and the Niwa team have 4 more days before they have to break up camp, but their luck runs out. The remaining 5 birds, which include 4 with video cameras, don't make it back in time. Then, the COVID-19 pandemic means fieldwork in Antarctica is cancelled for next summer, so it'll be 2 years before Geeta gets back to Cape Crozier to carry on work. Good luck for that trip when it happens. You've been listening to Voices from Antarctica from RNZ. I'm Alison Balance. A big thanks to Antarctica New Zealand for hosting me and my microphones. Special thanks to the Niwa Penguin team, Geeta McDonald and Parker Foreman from Moss Landing Marine Laboratory, Marcus Horning from the Alaska Sea Life Centre, and David Thompson from Niwa. Thanks too to Adrian McDonald and Graham Plank from Canterbury University. You can find Voices from Antarctica, including photos, at rnz.co.nz/Our Changing World, or find us as a podcast. Just search for RNZ Our Changing World. Catch you next time. Kia ora mai.